Excellent, and we're live. And there's actually already 3 people waiting for us because I said I was going live at 9:33, so good for them. So, number 1, in Google Classroom, there is an assignment that some of you have already done involving Desmos. Now, that assignment, I'm still expecting for you to get done. You have to go to the assignment, log into your school account on Desmos, or create an account using Desmos and blah, blah, blah. You'll be able to see it and just walk through the assignment. It's pretty self-explanatory, the Desmos assignment. It's just kind of walking you through step-by-step certain things and asking your opinion on how you would answer certain questions. That Desmos assignment is going to inform a lot of the information that I am going to be teaching over the next several class periods, because I'm actually going to see you 3 times this week. Is no one excited? My heart just kind of broke apart a little bit, but I'll mend it back together eventually. So that's where we're at. My goal for today is to continue what we started last week. Last week, I started you on synthetic substitution, that little synthetic bar, which I am going to remind you of because it's been a week for some of you. And I want to take that synthetic bar and actually do what it's meant for, the synthetic division of certain polynomials. Now, the tricky thing about these dividers on your desk, for those of you in the chat, you can't see it, but they all have dividers on their desk. The tricky thing is it's kind of tough to have the Chromebook open and to have the notebook open. I'm going to try and not do both at the same time as much as humanly possible, but obviously there's going to come a time where, unfortunately, I can't get around that. But in the meantime, regardless, I'm going to need those notebooks out and open. Get them out, them notebooks. Now, for those of you that are in the chat right now, I'm going to try and have the chat open on my desk so I can also see what you're saying if you have the questions to ask. Let's see what we got here. Desmos. There we go. Good for me. I'm going to take, where's my mouse? I'm going to take this, move it over here. Cool. And I'm going to have this. Flip that over. There we go. Aha. Oh, that's way zoomed in. Hold on. Let's undo that. There we go. Big. There we go. Perfect. Zoom in out, zoom in out. Okay. I don't know if you've all seen this before. Have you guys ever had a teacher use one of these? No? You're still not going to have a teacher. You're not going to see a teacher use one of these until they actually fix up my computer. These things, it's supposed to okay. Last week, IT guy comes in on a Friday. And he's installing the stuff on my computer. And he hands me this thing. And he says, here, you're going to use this thing. And I'm like, what's this thing? He's like, well, there's like a digital pen. And you can use it. And it interacts with the smart board that you have when it's open and you're ready to go. I'm like, oh, that's great. It interacts with my smart board. Yeah, it interacts with the smart board. And he's like, why don't you have a smart board? I'm like, dude, I've never had a smart board. He's like, why not? I'm like, well, when they bought them all for the district, they ran out of money. And I was on the bottom of the totem pole. So I didn't get one. So so what'd you do? And I'm like, well, they gave me a smart board projector. It was one of those things, like you see the screws up above? There's like holes in the wall. Yeah. They installed a projector which overhang and then projected onto here, and it acted like a smart board. It never worked. It never calibrated correctly. And then the bulb blew. And then when the bulb blew, the guy came in and he's like, yeah, we're not actually going to replace the bulb because it costs too much money. So we're just going to uninstall it. I'm like, great. So not only did I not get a smart board, not only did I get a smart projector that never worked, but now you have these teachers, and I'm sure you've seen them. Have you seen these teachers with these giant brand new smart boards that are like TVs? Yeah, I don't even get that. So I just wanted to point that out there. You all should advocate for me. No? All right, same story. Back to this. Fun stuff. Ladies and gentlemen, in your notes. Today is the 16th. I'm going to have to zoom out on my camera in a moment. Zooming out, zooming out, zooming out. There we go. And we're going to call this Solving Polynomials. Let me show you exactly where we're headed with this. So let me give you a basic example. F of x equals x cubed plus 9x squared plus 26x plus 24. Now this example we are going to do completely together. It's going to be phenomenal. I've made it, and it may not look like this, but believe me, these numbers actually work out quite nicely. I got to move it up on the screen for those of you in the chat. You can't see some of those numbers. There we go. Hopefully you can see that a little bit better. Now, this is a cubic equation. This is a third-degree polynomial. Now, there are certain definitions that go along with that I'm going to give you after the first example. But being that it is a third-degree polynomial, that means at most, we could have 3 real solutions. At most. We might have less. But there's a possibility of having 3 solutions, 3 x-intercepts, 3 zeros that we can find. And we can set this up using what we did last week with that synthetic bar. So now that's what I actually want to do. I want to set up this synthetic bar where I put a 1, a 9, a 26, and a 24.
K through O, that's K through O, can report to the main lobby for cap and gown wearers. That's seniors with initials K through O, main lobby.
Okay. I put these numbers here. These are the coefficients on the problem. Now, the coefficients go in order from the largest exponent down to the smallest, meaning this is a 1x cubed. It's a 9x squared, it's a 26x, and it's a 24. The problem with using this synthetic bar the way that we need to is we don't have a number to go right there. We don't have a number to go on the outside. See, again, just as a reminder to last week, and I'll go over this in more detail with you, when we do this synthetic bar, this synthetic division, there's a repeated process of adding and multiplying, adding and multiplying. But we need to know what number is going on the outside, but we don't have a number. Oh, no. Could you guess at a number? Of course you could guess at a number, but I don't want to guess at a number. Now, when you're doing these problems on your own, you will have a graphing calculator on your Chromebook. Now, I'm not asking for them now. You keep them to yourselves. But I'm going to put this into my graphing calculator. And I'm going to take a look at as to what this thing actually looks like. So let me zoom in a bit. Now, again, you don't have to do this right now. I'm just going to do this for you so we can visually have something. X to the third plus 9x squared plus 26x plus 24. Oh, that's a 27, 24. There we go. Always double check. So, hey, quick fun fact. You guys know how you have a square button, right? Did you know you also had a cube button? Some of you. Some of you are nodding yes. Some of you were like, what the heck? If you actually hit math, you do have a cube button right there. But not dealing with that right now, just looking at this graph. Let's take a look visually. Here's what the graph looks like. Ha 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 ha. Oh. Look what this graph does. Now, again, of course, you would have your own graphing calculators to do this thing. We're doing this one together right now. This graph came up, seemingly crossed the x-axis, came back down, and then shot back up like that. Interesting. That's what this graph seemingly has done. If you had to guess, and again, I emphasize this is just a guess, a visual guess. If you had to guess a number for which it crossed the x-axis? What would you guess first? What kind of number do you think represents an x-intercept on this graph? Would you say it's positive or negative? You say it's a positive number. It actually would be negative. Yeah. Do you know why? Check this out. X-axis. X-axis. There's 0. There are your positive numbers. There are your negative numbers. That's okay. That's okay. You're fine. That's okay. Do you want to redeem yourself? Yeah. Okay. Can you guess what negative number might work as an x-intercept? Well, it's not specifically any, but I just want to know, what do you think visually it looks like? -3? Maybe. Let's find out. Honestly, this is the thing. What I'm doing right now, the process that I am verbally going through with you, is the process that you would go through. You would look at the graph. You would look at the graph on the calculator, and you would visually identify whether or not you could see any zeros. You're saying -3. Now, is she correct? I have no idea. I have no idea whether or not you're correct. You could be. You might not be. I don't know. Absolutely. But let's just see what happens. Let's just see what happens. So I'm going to go back to this synthetic bar. And I am going to see, okay, maybe -3 will work. Let's try it. Let's put that -3 on the outside. Now we have a way of beginning this synthetic process. Now we have a way of beginning it. So let's do it. All right. If you happen to remember last week, the synthetic bar was nothing more than addition and multiplication, back and forth until you get a number down here where I'm pointing. So it would be 1 plus nothing, which is 1. Yay. And then we multiply. I'm going to say this statement. You always multiply by the number on the outside of the bar. You always, the one that I'm pointing to. You always multiply by that number on the left. 1 times -3 is -3. Put it in the first blank spot. Then I go back to adding vertically. And I get a 6. And then I multiply by that -3. I get -18. Question, before I finish it, question. I have no idea whether or not -3 is going to work. But if it does, what number should I get right here? I should get a 0, if it works. If it doesn't work, then we'll talk about that when we get there. All right. Add them vertically. I get an 8. Oh, holy crap. I can already see that it's going to work. 8 times -3. Okay. Add them vertically. I'm going to get a 0. It worked. Now, this is proved. This right here proves so many things. So many things. Sorry, I'm looking at the chat. He says 8. Oof. Oopo. And I'm trying to look at the chat right now. I don't know what he's typing. I don't know. Anyway, back to this. This proves so many things. This.
All seniors with the last name beginning K through O, please report to the main foyer. All seniors, last name beginning K through O, please report to the main foyer. Thank you.
Okay. Good. So, this proves so many things. This proves that -3 is indeed an x-intercept. This proves that the factor x plus 3, I'm going to actually write this down a little bit, but x plus 3 divides this polynomial. This 0 proves that when you plug in a -3, oh my Lord.
Sorry for the confusion. It's letters P through T.
I feel like kicking a desk. Anyway, when you plug a -3 into this function, you get a 0 back as the output. So let's see what happens here. Let me write down some additional information for you. First of all, this 0 proves that when you do f of -3, you get 0. It shows that definitively. It proves -3 is a 0. It also proves that x plus 3, notice the emphasis on plus because it would be x minus -3. It proves that x plus 3 is a factor. All of this information right here is unbelievably important. All of this information here is unbelievably important. Victor? Hi. Miss Ayers called. She says that she's expecting you. Oh, you already did? Today? Oh, okay. There we go then. All right, cool. So are you here for today? Yeah. All right, cool. I have you in that desk because someone's already sitting there. Yeah. Ah, my cord is caught. What's going on here? There we go. Good. All of this information, ladies and gentlemen, is unbelievably important because getting that 0 in that spot in the synthetic bar proves all of these things right here. If you did not get a 0 in that spot, now remember before you told me -3 and we said maybe -3 would work. If it didn't work, one of two things could have happened. Number one, if you didn't get a 0 there, maybe you made a mistake and we'd have to double check our math. Or perhaps -3 is not the number that you needed. Perhaps it was a different number. But let's continue. See, the thing is, if I'm going to try and finish this problem, if I'm going to finish solving this problem, I got to understand something. These numbers right here, show the result of division. These numbers show the result of division. Let me show you what I mean, because I'm going into much more detail than I did last week. Here we go. Write this down. If I took this original problem and I divided it by x plus 3, let me move that up a bit. If I took that original problem and I divided it by x plus 3, I just showed before with that synthetic bar that x plus 3 is indeed a factor. We have proven that it is indeed a factor of the problem. We showed that with the synthetic bar getting a 0 in the last spot. So if it's a factor, then this must divide evenly. It must divide evenly with no remainder. And in fact, if you remember, this number represented my remainder. I have a 0 remainder. Remainder nothing, which is good. But the result of this division, these numbers right here show the result of the division. And if you remember what we did last week, each of those numbers represents something very important. I'm going to write it down and then we're going to talk about it. Write down that equation. If this 0 is the remainder, working backwards, then this number is my constant, this number is my x, and this number is my x squared. The numbers on the bottom of the synthetic bar represent the resulting equation. They represent the resulting equation. And we are going to break this thing down piece by piece. Now, let me show you something. I showed you this last week, and I want to show it to you again. Look at this, look at this, look at this. Zoom in, zoom in, zoom in, zoom in, zoom in. Change the size of my window here. Nope, let's go to -8. Let's go to -5 to 5. Graph. Look at this graph. Look at this graph. This is the same graph. This is the exact same graph that we just did. Right here. Look at that visually. That is the same exact graph that you just saw before. What number did we just plug into the synthetic bar? What number did we just test to see if it worked? -3. Watch this. Boom, boom, boom. Look what's blinking on my screen right now. We just tested -3. There's that -3 right there. Watch what I'm about to do here, because it's going to mess your heads up. Check this out, check this out, check this out. Look what I'm about to do. Look at that y equals k. Look what I'm dividing by. You would not have to do any of this on your own. I'm just trying to show you visually what's happening with this problem. I'm dividing my original equation by the factor x plus 3. Graph. Notice that I divided by x plus 3. I divided by the factor x plus 3, which gets rid of the 0 of -3. Notice that my resulting graph in that division does not go through -3 anymore. I have divided it out. But it has the exact same zeros that we had earlier. By the way, I don't know if you guys know how to do this with the graphing calculator. Check this junk out. Ready? I don't know if you know how to do this, because I don't know if anyone's ever taught you. But did you know that you could actually go there on the graphing calculator? Look where I'm blinking. Look where I'm blinking. You can change the type of line that you graph. People don't know this stuff about the graphing calculator. Where if I click it once, what happened to the far left line? What happened to it? It's thicker. It's bolded. What's going to happen when I hit graph? What's going to happen when I hit graph is that this second equation is going to graph directly on top of the other curve. Watch this. Here it comes. Woo! It's kind of nice. It basically proves that this second equation, this quadratic, this x squared plus 6x plus 8 is the result of that division. It's really kind of nice. Now, obviously, I'm not going to go into this much detail with my other problems, but I'm just trying to show you how this works, how this process works. I'm going to put a little note here, a little bullet point here. The bullet point is, once you reduce equation to a quadratic meaning that you have an x squared, you have options. You have options. You have options as to how you continue with this particular problem. Option number 1, you can continue synthetic with quadratic. And I'm going to show you how to do that in a moment. I'm going to show you how to do that. Option number 2, you can factor the quadratic. By factoring the quadratic, you can easily get the remaining answers that you're looking for. But we really only have methods for factoring quadratics. We don't have a method for really factoring a cubic or a quartic. Only really quadratics. Option 3, quad formula. Basically, you choose whichever option works best for you, and then you continue. You choose whichever option works best for you, and then you continue attempting to solve the problem. Synthetic division is going to be used up until, I should say, a certain point. And then from there, well, once you get to a quadratic, you can choose what to do. Let me move that over here. He's saying he can't read that. What particular portion is he attempting to read? I'm going to move it up like there. See if you can see that a little better. Is that a little easier? I'm talking to people in the chat. Here's what I'd like you to do, because I'm going to try and move this up so you can read a little better. I need you to write this problem one more time, because we're going to go through it again in good detail. Write down the exact same problem, because we are not done with it yet. The exact same problem that we started with. Write it down again. So, this is you on an assessment. This is you facing one of my assessments. It could be an online assessment. It could be anything. Quizzes, Edulastic, whatever. Link it. Who cares? And I tell you with this particular problem, factor completely, find all zeros. Those are the directions now. The directions that I give you on this particular problem are to factor completely, find all the zeros. So you have options as to what you want to do first, but let's start the exact same way that we did. So you as a student, typed that equation into a graphing calculator, into something, and you visually identified -3 as a 0. Yes, I'm doing it again with -3 just to show you something else. We're sticking with the same problem. Now, -3 is the possible 0 of the function. Someone get that door? -3 is the possible 0 of the function. The 1 comes straight down. I multiply. I add. I multiply. I add. I multiply. I add. Having that 0 there proves that I have found the correct 0. Now, I haven't found all of the zeros. I have not found all of the zeros. I've just found one of the zeros. I need to continue with this process. Now, just as a reminder, this is my equation that I have left over. I have that equation left over. That last number, remember, is my remainder. Then the 8 is my constant, the 6 is my x, and the 1 is my x squared. It's a 1x squared, really. I am going to do another synthetic division. I'm going to do another synthetic division. But this time, these are my numbers right here. Hold on.
Elizabeth Retorto, please come to main office. Elizabeth Retorto, please come through to main office.
I'm going to do another synthetic division, but this time I'm going to do... hold on. What can I throw? Where's my tennis ball? Oh, good call. Yeah. I'll throw it when you least expect it. Anyway. But I'm going to do this synthetic division again. So now here's what I got to do. All right. Let me get rid of this. Oh, yeah, let me get rid of this and this. There we go. So here is what you would have typed in originally. Zooming in, zooming in, zooming in, zooming in, zooming in. Here's what you would have typed in originally. And you would have been like, okay, I think -3 works. Can you guys identify another number that might work besides -3? Could you identify another number that works besides -3? Here's the graph. I just zoomed in. What else might work? Sure. It could work. What else could work? Okay. -4 and -2 look like they work. You need to prove it. Here's how you prove it. Zooming out, zooming out, zooming out. Let's try the -4 first, since that was the first number that was shouted. Let's try the -4 now. So, down comes the 1. Multiply. Add. Multiply. Add. That is your remainder. You have proven that -4 works as a 0 of the function. You've proven it right there. Proven. Now we have, again, a few options, but I want to talk about this. If this 0 is your remainder, do you guys remember what this 2 is at the bottom? What did I keep calling it? The first number to the left of the 0. Starts with a C and ends with an constant. You got it! Yeah! Woo! That 2 is your constant. What does this 1 represent? What term does this 1 represent? Think back to what it represented up here. This 8 was your constant, and this 6 was an x term, and this 1 was an x squared. Down here, this 2 is your constant. What's this 1? It's your x term. That's a 1x plus 2. That's a 1x plus 2. At this point, you legitimately could just solve that. You could legitimately just be like, okay, yeah, it's -2. Didn't you tell me the other number was -2? Yeah. X plus 2. Oh my goodness. Okay, hold on. This is going to be impressive. Check this out. This is the resulting factor. Now, again, you have options. You could just solve that right now. Set it equal to 0 and solve. You get -2. Yay! Or if you really wanted to be weird about it, you could do this, although you really don't have to. You really, really don't have to. 1, -2, 0. Yay! So what this does is this. We have proven that -3, -4, and -2 are zeros. We have proven that -3, -4, and -2 are zeros. This also shows, my marker's dying. Get a new one. I missed. I know, but I didn't want that marker anymore. This also shows x plus 3, move this up a bit, x plus 3, x plus 4, and x plus 2 are factors. We have answered the problem. We have successfully answered the problem. The problem was, hey, factor completely, find all the zeros of the function. We've done that. We've proven it. The synthetic division, now I did this the very long way, the very, very long way. I'm going to go through an example with you where I do a little bit of a shortcut to show you what you could do. But I wanted to show you each step of this process so that you can see what happens. Let's try a slightly new problem. Let's do that one. Good. Let's do that one. Slightly new problem. Example. f of x equals 3x cubed minus 8x squared minus 5x plus 6. Slightly new problem. No, slightly new problem. It is a new problem. Now, I'm going to walk you through this problem and show you exactly what you could do given everything that is at your disposal. So what's at your disposal? Your graphing calculator. Again, I didn't ask for them to be out because it would be a bit too cumbersome. But I typed it into my graphing calculator, and I'm about to zoom in and show you exactly what happens. Hold on, it's got to focus. There it is. Show you exactly what happens with this thing. Let's graph it. Graph. Okay, that happened quickly. Let me show you again. I'm going to walk up to the board. Hold on. Here we go. I'm going to zoom in just a little bit more so you can see it happen again. Here it comes. Boom, boom, boom. Looks like here, here, and here. What do you think that number is right there? What do you think that x-intercept is? The one that I just pointed in a little arrow to. -1. Looks like x equals -1. What about this one up here? Looks like +3. Looks like +3. That one, why is that one a little trickier? Why is the one in the middle a little trickier? It's not a what? It's not a whole number. I don't know what that is. It could be a half. It could be. For all we know, it could be. I don't know what that middle number is, but here's what I do know. Since we were able to identify this one and this one, we can easily find that third one. We can easily find that third one. Let me show you what I'm talking about. It looks like +3. It looks like -1. Let's go to synthetic division. I'm going to go back here. +3. Let's start with the +3. I'm going to use a bar here. 3, -8, -5, +6. Those are the coefficients I get from the equation. It looks like +3 is a 0 of the function. If I'm right, I should be getting a 0 in this bottom right corner. I'm pretty confident that we're right. Well, let's just see what happens. 3 plus nothing is 3. Multiply. -8 plus 9 is 1. Multiply. -5 plus 3 is -2. Multiply. 6 plus -6 is 0. It worked. It worked. Now, we're not done yet because we have other zeros to find as well. What results is the equation 3x squared plus 1x minus 2. Now, again, at this point, you have options. You took this cubic, you divided it by a factor, and you've reduced it to a quadratic. Once you get to the quadratic, you have options. You can try to factor it. You can try to do the quad formula. Hold on.
Please excuse interruption. Elizabeth Retorto to report to the main office.
Did it break? It's still working. All right, I was hoping I'd break it. One of these days. I should. One of these days. You guys see the scuff marks around there? Yeah, that's years of abuse. Yeah, maybe. I don't know. One time I was teaching the class. I was facing this direction. And out of the corner of my eye, one of my students in a different class was just at the window. And I ignored him. because he's just trying to disrupt. I don't know what he's doing in the hallway. This is last year. And so I had like the marker in my hand, and just on a whim, I decided to take the marker and full on just whip it at the glass door while his face was right there. Nailed the glass right in front of his face. Marker shattered into a bunch of pieces. Lost the marker. I still regret it. Anyway, there's no point to that story other than that. Back to this. You have options. Now, of all the options, will factoring work? Maybe. Maybe factoring will work. I don't know. Quad formula. Will quad formula work? Yes. Quad formula will always work. Will synthetic work? Here's the thing, and I want to be very clear with you. The only way you are going to be able to continue with synthetic is if you are able to identify more zeros, which we think we do. We think we have -1. The only way you're going to be able to continue with synthetic is if you can identify more zeros, which we think we have. We think -1 is going to work. Let's try it. Let's try -1. So I'm going to bring down that 3. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. It worked. It worked. Now, this is the most important part of this problem. This, right now, this moment is the most important part of this problem. Look where I'm pointing. Look where I'm pointing right here. The number that I'm pointing to is your remainder. Remainder. The number that I'm pointing to right now is your constant. The number that I'm pointing to right now is your x term. It goes remainder, constant, x, and then if you have more terms, you'll have more terms. What that means is you have a 3x minus 2. Oh, there it is. A 3x minus 2 as the resulting equation. It is a linear function. Look what you've just done. Now, we're not done yet, but look what you've done so far. You've taken a cubic third-degree polynomial, divided out a factor, got a quadratic. Divided out another factor, and you got a linear. You keep reducing it, reducing it, reducing it to find all the possible zeros. At this point, I'm going to do this. Equals 0, I'm going to solve it. I'm just going to solve that. Now, remember, we didn't know what decimal it was. It could have been 0.5. What was that decimal you said earlier? It was like 0.7 something? I don't know. I don't know what it was, but it was something. Here's the thing. If you solve this, you end up with the fraction 2/3. You end up with the fraction 2/3, which is a decimal, which is 0.6 repeating. But that is the exact answer. So here's what we've proven. We have proven these are the zeros of the function. We have just proven that those 3 numbers are zeros of the function. And we have proven that these are the factors. This is a shortcut version of this problem, but this is what you could do. 3 is definitely a 0. We proved it right there. -1 is a 0 of the function, and we proved it right there. 2/3 is a 0 of the function. We proved it by doing this. As a result, 3x minus 2 is indeed a factor, as are these two right here. This is what this problem does. It is phenomenal. It is phenomenal. I love it. All right. I got one more amazing problem for you. I have one more amazing problem for you. I want you to note something right now. I want you to take this moment in right now, this moment that we're all sharing right now. If this were last week, I would have had to rush through a lot of this information just because of the nature of what we were doing. But this week, I have you Monday, Wednesday, Friday, and I can take my time with these problems. Think about it. This is only the second problem I've done today. I love having more time. I love having more time to get these things done. Here we go. Get ready. New example. F of x equals x to the fourth plus 3x cubed plus x squared minus 3x minus 2. Look what we got here. I'm going to type it in so you don't have to. But that's the example that we are about to rock out to finish up this class period. Zooming in, zooming in, zooming in, zooming in, zooming in, zooming in. There it is right there. Look, 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 look. There's the equation in all of its glory. I'm going to hit graph. Graph. Ish. Unfortunately, I don't think so. My son uses the inside of his mask. It is disgusting. I don't recommend it. I don't recommend it. Is that yum? Look right here. Look at this graph. It looks like the bottom of Florida or like a pen or a boot. I don't know. Whatever. Let me change the size right here. Check this out. Here it comes. Yeah. Name where you think it might cross the x-axis. Looks like -2. Hold on. -2. Hey, that could work. Name another place. Name another place where you think it might cross the x-axis. -1. -1 does work. +1 does work. Now here's the thing. Just because I just did that on the calculator does not prove anything. The way that you are going to prove it, the way that you are going to show me algebraically is by doing synthetic division. This is the way that you're going to show me algebraically. All of those numbers seemingly work. Let's see what happens. So, synthetic bar said -2 was the first number I heard. Let's do that one first. This is a 4th degree polynomial. A 4th degree polynomial. The largest exponent is a 4. It is known as a quartic. Quartic. Let's figure it out. This should work. Let's see. 1 plus nothing is 1. Multiply. Add.
And last announcement. At this time, any juniors and maybe even seniors who want to order rings, Mr. Santos is in the main lobby for ring orders. Thank you.
Yes? Yes. Yeah, just, you can go. The bell, it's not going to ring for like another 4 or 5 minutes, but, you know, I don't think anyone's going to stop you. Yes, you should, as you should. Multiply, add, multiply, add, multiply, add. Now you have to be very careful with your multiplying and your adding. This is what we did last week. Adding straight up and down, you always multiply by the number on the outside. Now, this is a really messed up cubic equation. This is a really messed up cubic equation. In fact, if you did this backwards, this would be your constant, your x, your x squared, and your x cubed. But I'm not worried about that. Look what I just did. Look what I just did. What I just did is I just took those numbers that would have been in my equation, and I just created a brand new synthetic bar. What was the other number, the second number you guys said? -1? Let's do that one. Let's do that one. Let's do -1. Yes, let's do -1. Let's see. 1 plus nothing is 1. Multiply. Add. Multiply. Add. Multiply. Add. It works. Now hold on just a second. Look at the equation you have left over. There's your remainder. There's your constant. There's your x. What do you notice about the x term that I'm pointing to? Which means it won't even be in the equation. Yeah. But then you still have an x squared term. This really is 1x squared minus 1. That's what you really have there, because that x term is a 0x. Now that I have it as a quadratic, check this out. The quadratic that I have left over is x squared minus 1. I can factor that. I know how to factor that. Should be like x minus 1, x plus 1. That's what it factors into. That's what it factors into. Now, again, you could continue with synthetic. Or, since I've already factored, why don't I just solve it? X minus 1 equals 0. X plus 1 equals 0. I could solve those. Zoom in. I get x equals positive 1. X equals negative 1. But don't forget these two numbers over here, the ones that I'm kind of trying to point to right over here. Do not forget these two numbers on the side right here. You proved those earlier. X equals negative 1. X equals negative 2. Somebody tell me something about the zeros. Somebody tell me something about the zeros that I just circled. Something that you need to recognize before we move forward with anything else. What is something that stands out? Something that leaves you a little bit like, wait a minute. How is that possible? What do you notice about these four numbers? Ooh. Someone's got to recognize it. Someone's got to recognize it. This is going to be messed up. It's going to be amazing. I wrote -1 twice. I wrote -1 twice. Look at this. Look at this graph right here. I zoomed in a bit on the graph. This is the same graph that we just did. This is the same graph that we just did. Hold on, it's got to focus. Hold on. It's got to actually focus the screen. There it goes. Look at this. Look. There's -2. Don't be moving on me. Don't be moving on me. There's +1. And there's -1. What do you notice about the graph? What do you notice about the -1? Cuts right through -2. Cuts right through -1. Oh, I messed up. There we go. What do you notice about -1? It just skims it. It just hits it and turns the other way. That is a characteristic of what we call a repeated zero. We will get into more details of this on Wednesday. I'm going to give you those definitions that I talked about, the definitions in terms of the degree of the polynomial and repeated zeros and how many zeros we should be expecting to get and things of that nature. And of course, we will also get practice with this. I do enjoy having more time to dissect these things with you. I do enjoy more because I have more time to do it. Otherwise, this would have been like I would have had to rush through a lot more stuff. Anyway, I'm going to sign off. Bell's going to ring right about now.